Okay, in the next example, we're given this quadratic function, x plus 2 squared. We have to write and simplify equations again and then do some graphs. But this time, instead of doing f of negative x or negative f of x, we sort of want to do both, minus f of minus x. So let's give a moment's thought about that, because what we need to do is reflect over the x-axis and then reflect over the y-axis this graph. Well, let's work with the algebra first, and then we'll think about what the graph or the geometry of that's going to look like in just a moment. Okay, so let's start with f of negative x. So given f of x, we have to do two things. We have to first put a negative sign out in front of the whole f of x function, but then instead of writing f of x, we have to sub in a negative x where the x is. So we end up with something like this. Okay, so we don't really need the square in the round brackets. I just put that there for clarity's sake to start off with. What we end up with is something like that. Now it does say simplify, so let's expand the bracket here and then bring the negative through just to see what we get. Well, if we multiply this out, it's a binomial square, so we have to square the first term, which is minus x squared, which you might have thought is just x squared anyways, and that's okay, that's what it is. And then the cross term is a negative x times 2 and then doubling that. So that would be minus 2x, and then double that is minus 4x, and then we just have the 2 squared on the end, which is a positive 2. But then we have this negative sign out in front, so first I guess I'll be careful here and write this as x squared, as we had mentioned, and then we have minus 4x plus 2, and the negative sign out in front says just to change everybody's sign. So we end up with minus x squared plus 4x minus 2. Okay, fine. That's the algebra. Now let's see what it looks like if we graph it. Well, the original function, of course, you might remember, is a parabola that's been translated 2 units to the left, and we're going to go over 1, up 1, over 2, up 4 units. And those are 4 nice points on a parabola. See how I can do drawing with some mouths. Not bad there. Oh, a little got crazy at the end, but should go up a bit better like that. We can fix that up here with a little bit of an eraser. Okay, anyways, we're doing pretty good. There's our original parabola. Now, this is the final equation, and I could graph that by completing a square or turning it into vertex form with equation minus b over 2a, but instead I'm going to use our transformations, our reflections to do so. So let's start with the vertex. We have to reflect it over the x-axis and over the y-axis. So over the x-axis, that's this negative sign here, over the x-axis, goes nowhere because it's on the x-axis. Over the y-axis, puts it right there. Yeah. This point here, reflected over the x-axis, goes down to here, and then over the y-axis, he ends up right there. So it's down and then over. This point again, over the x-axis brings the y-coordinate down to -1, and then over the y-axis means instead of having -3 as the x-coordinate, we now have +3 over here. And let's move to this point over here. So we've got a -4 and 4. So over the x-axis puts it down to 1, 2, 3, and 4. And then over the y-axis puts it back over here at 4. And finally, our y-intercept of the original, which was a 4, ends up reflecting over the x-axis to -4. And then since it's on the y-axis, it doesn't reflect at all. And so we end up with our parabola. Oops, a little dent in the side there, but that's our parabola minus f of minus x. So once again, we've reflected over the x-axis and then over the y-axis. You might ask yourself if it mattered what order we went to, because we went over the x first, then over the y. But as you can see, you could reflect any of these points. You could reflect over the y-axis and then over the x-axis. You'd end up in the same spot. Try this one here. It's at -3, so over the y-axis puts it at +3, and then bring it down over the x-axis. It ends up in the same spot. So in this particular case, these double transformations here, these double reflections, it doesn't matter in which order that you apply them. That won't be the case for all transformations, but it is for reflections. Okay, so take a moment to look over that example, make sure you understand it, replay the video if you need to. When you're done and you're ready, I'd like you to work on these questions. And those are to be found on a handout on the VeraCross website, and I'd like you to do the following numbers. Now, this is posted on VeraCross, so if I can get us over to VeraCross to here, you can see that here is the reflections handout. So if you click on that, it'll open up. You can see all the questions that I want you to do. Solutions are down at the bottom. Right here. Okay, and going back to the web page, you can see on the calendar that this work has been posted and it's due for Thursday's class. Oops, sorry, that's not you guys. That's the other group. You guys are group 1. It'll be posted for Wednesday's class when hopefully, there it is right there, Wednesday's class, I'm back at school. Okay, well, hope that's helped. Good luck with your homework. See you soon.